Hello, dear students. Today's topic is acids and bases. This is included in the syllabus of first semester inorganic chemistry of B Pharmacy. So let's go for the concepts of acids and bases. The first concept is Arrhenius concept. Second is Bronsted and Lowry concept, while the third one is the Lewis concept. So let's go for the first concept, which is called as the Arrhenius concept. According to this, acid is any substance which is capable of providing hydrogen ion in aqueous solution. For example, hydrochloric acid HCl in aqueous solution liberate a proton to form hydronium ion and chloride ion. Likewise, nitric acid HNO3 gives a proton in aqueous solution to form hydronium ion and nitrate ion. So though HCl and HNO3 are giving H plus ions in aqueous solution, they are considered as the acids. Let's go for the bases. According to Arrhenius concept, base is any substance which is capable of providing hydroxide ion in aqueous solution. For example, sodium hydroxide in aqueous solution gives sodium ion and hydroxide ion. Likewise, potassium hydroxide KOH in aqueous solution gives potassium ion and hydroxide ion. Likewise, calcium hydroxide in aqueous solution gives calcium ions and hydroxide ions. Though all these three compounds gives hydroxide ion in aqueous solution, they are called as bases according to Arrhenius concepts. The second concept is the Bronsted and Lowry concept. According to this, acid is any substance which is capable of donating a proton in a chemical reaction, while a base is any substance which is capable of accepting a proton, that is H plus, in a chemical reaction. Acids are simply called as proton donors, while the bases are called as the proton acceptors. Let's look at these examples. HCl in aqueous solution gives formation of hydronium ion and the chloride ion. Here HCl gives a proton to the water. So HCl is called as acid, while water is called as a base. Here HCl is liberating a proton and water is accepting a proton. The base water gives out conjugated acid, while acid gives out conjugated base. Let's look at the second example. Water react with ammonia to form ammonium ion and hydroxide ion. Here, water acts as an acid because it gives a proton to the ammonia. Ammonia is accepting a proton from water. So water is acid, which gives out conjugated hydroxide ion, a conjugate base. Ammonia is a base. By accepting a proton, it gives conjugate acid. The next example is sulfuric acid and hydroxide ion. Sulfuric acid gives a proton. It donates a proton to the hydroxide ion. That means hydroxide ion is accepting a proton. So though sulfuric acid is donating a proton, it is called as acid. Hydroxide ion accept a proton, so it is called as a base. Sulfuric acid gives the conjugated base bisulfate ion. The base hydroxide ion gives the conjugate acid water. The last concept is the Lewis concept. According to this, acid is any substance which is capable of accepting a share in pair of electron in a chemical reaction. Simply, according to Lewis concept, acids are those substances which accept a pair of electron, while base is any substance which donate a pair of electron. Let's look at this example. Boron trifluoride BF3 in a reaction with fluoride ion gets converted to BF4 anion. If we look at the structure of boron trifluoride, we will find that the central atom boron is surrounded by only 6 electrons. So, to complete the octet, it requires a pair of electrons. So, it is in need of a pair of electrons. That means it can accept a pair of electrons. That's why BF3 is considered as acidic in nature. The fluoride ion having a pair of electrons to share can act as a base. So BF3 accepts a pair of electrons from fluoride ion. So fluoride ion gives a pair of electrons, so fluoride ion is called as Lewis base, while BF3 is called as Lewis acid. Both combine to form the adduct BF4, that is boron tetrafluoride anion. Let's go for the next example. Let's look at this example. This is AlCl3, that means aluminium chloride. Like BF3, here the central atom aluminium is surrounded by only 6 electrons, these electrons. So to complete the octet, it is in need of a pair of electrons. So it can accept a pair of electrons. That's why aluminium chloride is acid in nature. Ammonia with a pair of electrons will act here as a base. This unchaired pair of electron can be donated or can be shared with the aluminium of aluminium chloride. So AlCl3 will act as an electron pair acceptor and hence an acid. Ammonia with a pair of electron is a base. So here both combine to form this adduct. Let's look at the last example, zinc chloride. Here the central atom zinc is surrounded by 2 plus 2, 4 electrons only. So to complete the octet, it is in need of 2 pair of electrons. So zinc chloride can react with 2 chloride anions to form the zinc tetrachloride anion. So by accepting a pair of electrons from 2 chloride anions, the octet of zinc gets completed. So dear students, here zinc chloride act as an acid while the chloride anion will act as a base. So these are the concepts of acids and base according to Arrhenius concept, Lowry and Bronsted concept, and Lewis concept. So thanks for watching the video. Please like, share and subscribe. Thank you.